2, 3 testing, 1, 2, 3 testing. 1, 2, 3 testing, 1, 2, 3 testing. Let's increase. 1, 2, 3 testing, 1, 2, 3 testing. Okay. Okay. I'm going to talk about the cerebellum, and what we're going to talk about is what I want you to focus on. So I'm going to jump through a lot of slides and focus only on slides that I want you to really focus on for the upcoming final exam. Okay. So the first thing I want you to look at is basically how the cerebellum, the little brain, is connected to the brain, or the brain stem. And it's connected by 3 large tracts: the superior, middle, and inferior cerebellar peduncles. And so they connect the cerebellum to the midbrain, pons, and medulla respectively. All right. This just shows the surface of the brain. I don't want you to focus too much on this. And so talking about the 3 different tracts, what you're looking at the inferior surface of the cerebellum. And here, this is your superior cerebellar peduncle, middle, which is the largest, and then here, your inferior cerebellar peduncle. Okay. Again, we're just going to focus on things that are important. So, in terms of basic structure of the cerebellum, is that there's a small inferior part called the follicular nodular lobe. And let's go back up real quick and see if you can see that. Can't see it here, but let's go a little bit further down. You might be able to pick it up. And so this right here would be part of that follicular nodular lobe, okay? And then the neural part right here, the vermis. I talked about the vermis before. This is where you're getting your both your posterior and anterior spinal cerebellar peduncle will finally synapse onto the vermis. In addition, you have these 2 lateral hemispheres. And so these are these lateral hemispheres that are shown here. Again, here is your vermis right here. So your vermis is in between the 2 lateral hemispheres. Okay? And that's all I really want you to focus on in terms of the anatomy. Oh, and lastly here, this is kind of a faint diagram showing the follicular nodular lobe, which is also part of the cerebellum. Okay, go a little bit further. Again, in terms of what are the information that are conveyed or being carried by the cerebellar peduncles, the inferior is composed mainly of afferents to the cerebellum. Afferents coming in from the spinal cord as well as the brainstem. The middle cerebellar peduncle, which is what I said earlier, is the largest, and it is composed almost exclusively of these afferents that are coming to the cerebellum from these nuclei that are found within the pons called pontine nuclei. And what they're going to do is that they're going to give rise to these pontine tracts that are going to cross over to the contralateral side and enter into the cerebellum. And again, they're entering into the cerebellum via the contralateral, from these contralateral pontine nuclei. And they're entering into the cerebellum via the middle cerebellar peduncle. The superior cerebellar peduncle, and this is important and I want you to remember, contains the major efferent pathway from the cerebellum. It's not really important as to where it's projecting to, but just for consistency, is projected to the red nucleus and thalamus. This you don't need to know. What you do need to know is that the superior cerebellar peduncle contains the major efferent pathways, while the inferior and middle cerebellar peduncles contain mainly afferent pathways into the cerebellum. There are deep cerebellar nuclei. I'm not going to, the only thing that I ask you to know about them are their names. And so the first is the most lateral one, and again, I'm not going to hold you to whether it's lateral, medial, or in between, is the dentate nucleus. So the dentate nucleus is one of these deep nuclei in the cerebellum. The next is the emboliform, the globus nucleus, and lastly is the fastigial. And so I just want you just to remember the names, not necessarily where they're projecting to. Okay, and so this diagram shows the dentate nucleus here, the emboliform nucleus shown here, the globus, and the one most medial is the fastigial. The globus and the emboliform is referred to as the interposed nucleus. That's not important, but sometimes you'll see this, and that represents both of these two different nuclei. The other thing that I want you to focus on is, is here in terms of the afferents that are projecting into the cerebellum. The first is the vestibular system, and we're going to be talking about the vestibular system next week. So the vestibular ganglion nuclei, they're going to terminate in the cerebellum in an area referred to as a vestibulocerebellum. Okay, so what I want you to remember here is the afferents coming from the vestibular ganglia are going to terminate within the cerebellum. Okay, they're going to terminate either via the inferior middle cerebellar peduncle is where they're going to project into. The spinal cord is going to terminate into an area of the cerebellum referred to as the spinal cerebellum. Okay, and lastly, this cortical pontine cerebellar. Those are these cortical neurons are projecting into the pons, and then what they're doing is they're going to project from the pons into the contralateral cerebellum via the middle cerebellar peduncle. Okay, and that's all I want you to really focus on this particular slide into the afferents. And so this kind of goes over the major tracts into where they're projecting into. You have coming from the Clark's nucleus, the posterior spinal cerebellar tract. That's abbreviated as PSCT. It is projecting from a collateral direction. It's going to enter into the cerebellum via the inferior cerebellar peduncle. The anterior spinal cerebellar tract, originating from these anterior border neurons, they cross over, remember, to the contralateral side. They ascend, and they're going to enter into the cerebellum via the superior cerebellar peduncle. Then they're going to cross over, and they're eventually going to synapse within the vermis. And then here, that cortical ponto cerebellar tract is that you have cortical neurons that are going to project into the pons area right here. These pontine nuclei, abbreviated as PN, are giving rise to these contralateral tracts, and they're going to enter into the cerebellum via the middle cerebellar peduncle, and that's shown here. Okay, and so the thing I want you to remember is that the afferents are going into the middle cerebellar peduncle are coming in from the contralateral side, that is, coming from these pontine nuclei. Okay, and so here, this is shown, this diagram kind of represents what I just said in terms of kind of the basic mechanism. So this spinal cerebellar area right here, and the vermis would be right here. This is where you're getting these posterior spinal cerebellar tracts or these anterior spinal cerebellar tracts that are coming from the cerebellum. They're going to synapse into the cerebellum. The areas here, the cerebellum, this is where these middle cerebellar peduncles are going to synapse into this area of the cerebellum. They're the vestibular cerebellum right here. Okay, and so this right here would be your floccular nodular lobe. This is where your vestibular ganglia tracts are going to ultimately synapse within the cerebellum, within this area referred to as your vestibular cerebellum, also known as your floccular nodular lobe. Okay, and that's all I want you to know about that. Okay, and so this, again, floccular nodular lobe receives vestibular input, okay, and that's referred to as your vestibular cerebellum. And the vermis, okay, don't worry about this, the vermis receives spinal input, and so that's called the spinal cerebellum. Your cerebral cortex, via these pontine nuclei in the pons, form the single major input to the lateral aspects of the cerebellum. And that lateral aspect of cerebellum is sometimes referred to as your cerebral cerebellum. It's also called neocerebellum. Okay, so somatosensory information from mechanical receptors of the skin, muscle, and joints, they reach the vermis via the spinal cerebellar tract. And the cuneo-cerebellar tract, remember the cuneo-cerebellar tract is coming from that lateral cuneal nucleus. That's the upper extremity information. And so that's going to enter into the cerebellum, again, via the inferior cerebellar peduncle. Okay? And so this kind of, again, goes over a little bit. And the focus here is the, like the anterior spinal cerebellar tract. It's contralateral where it terminates and how it enters into the cerebellum via the superior cerebellar peduncle. The posterior spinal cerebellar tract originates in the Clark's nucleus. It's going to terminate in the vermis, and it enters into the cerebellum ipsilateral via the inferior cerebellar peduncle. The cuneo-cerebellar tract originates from the lateral cuneate nucleus. It's going to terminate in the vermis. It's going to enter via the inferior cerebellar peduncle. And then here, the only one I really want you to focus on are those that are associated with the vestibular ganglia, so that vestibular and ganglia and nuclei, they're going to terminate within the floccular nodular lobe, and they enter via the inferior cerebellar peduncle. Don't focus on the reticular cerebellar. And then your pontine, they're originating in the pons, and these pontine nuclei, they cross to the contralateral side. They're going to eventually terminate in the vermis. They enter via the middle cerebellar peduncle. Okay, and that's basically, and so that's about, and then lastly, this just shows your output from the cerebellum. Again, your output's coming in from your superior cerebellar peduncle, abbreviated as SCP. It's going to cross over, and that crossing over is referred to as your decussation of the superior cerebellar peduncle. And then it's going to send tracts to the contralateral side into the red nucleus and the thalamus. Okay, and all you need to know here is that this tract does cross over as it's ascending to the red nucleus on the contralateral side or the thalamus on the contralateral side. So it does cross. Then you also send a descending tract into areas of the medulla. Oops, excuse me. Areas of the medulla. And this descending tract also is going to be contralateral, and this is referred to as your decussation, decussation of your descending limb of the superior cerebellar peduncle. But again, it's going to originate from the contralateral side. and it's going to project to areas within the medulla. Okay, this is not important, and so this is all the information here in terms of, again, the superior cerebral peduncle crosses over, so you have the decussation of the cerebral peduncle. It projects to the thalamus, and also here it could project to the contralateral retinaculus. And so here, this is just showing the projection from the motor cortex. You have the parietal decussation crosses over, and it's going to innervate motor neurons within the spinal cord. Okay, and so that's all you need to know about this subject.